Hi everyone, let's do an interesting decibel question. How large a change in decibels is required if the intensity of a sound doubles? So we're going to go back to our decibel equation. Number of decibels is going to be 10 times the log of the intensity of a wave divided by the threshold of hearing. So the question is, if the intensity doubles, basically if this ratio of the intensity compared to the original threshold is 2, what change in decibels occurs? So if I plug the numbers in, 10 times the log of this ratio being 2, if I put this into my equation, log of 2 multiplied by 10, I end up with an answer of 3 decibels. Now, why is that an important thing to know? Well, it's important for a whole bunch of different situations. Now, one of them has to do with the fact that this logarithm situation with decibels is wacky math and a lot of people don't understand it. But if you have 2 dBs difference between two things, that means that twice as much power is absorbed or twice as much sound energy is blocked. So let's take a look at earplugs. Now, I copied and pasted some earplug pictures from online. This one has a noise reduction rating of 20, that's 20 dB. This one's a 29, and this one is a 32. So what's the difference between, let's go between these two, the 32 and the 29? Well, if there is a 3 dB change, that means the amount of sound energy that is blocked between the 32 and the 29 is twice as much energy is blocked by these green ones with a 32 rating than the 29. Well, what about between the 29 and the next pair down here, which are the 20? Well, the 29 to the 20 is a 9 decibel rating, and 9 decibel rating is 3 times 3, or excuse me, 3 plus 3 plus 3. So that's going to be 2 times 2 times 2 times. The math gets a little strange here. Every time you go up by 3 decibels, twice as much power is blocked. So 20 to 23 would be twice as much power. 23 to 20 to 26 would be 4 times the power, and 26 up to 29 would be 2 times 2 times 2, 8 times the power. So you actually have 8 times more energy that is blocked by an earplug that's a 29 compared to a 20. I told you the math is a little wacky, and most people are going to stop in the pharmacy and just say, "Oh, I want the green ones because they're pretty." That's what I might do if I didn't know the difference between decibel ratings. Here's another place where this pops up. Earphones. Now, my husband and I have a lot of grass that we mow, and so a couple of years back, I bought him this exact brand of headphones. And when I was looking at them, they came in these 2 types. One was a lower decibel rating and a lower price. One was a higher decibel rating and a higher price. What's the difference? Well, the 26 versus the 22, this means that this is going to protect the ears and block more than 2 times the amount of wave energy. So a lot of people are going to look at these and go, what's the difference aside from color? The internal technology protecting the ear from external sound. This is more than 2 times of the amount of energy that's going to be blocked. So I got him the good ones because I don't want to yell at him when he gets to be old. Now, the next thing where this decibel and intensity level comes in is your cell phone. And we all love our phones, but on our cell phones, there are bars. Now, the bars are an interpretation, a visual interpretation of the power or the strength of the electronic signal that you can get from a cell tower. Now, it's weird units, and you can look up these units. Some phones let you look this up directly. Some phones you have to work really hard to see it. But you can actually find within your cell phone menu signal strength. And the units are decibels related to milliwatts. Now, the milliwatt is a common unit of power used for a radio signal. and 1 milliwatt is about 0 dB. So as you get closer to 0 dB, you actually get a stronger signal. So anything that is closer to 0 is actually a better signal than something that is further away from 0. So a negative 79 is better than a negative 100. Now, explaining this to the average cell phone user is complicated. Because of that, they give you a visual representation on your phone and they relate that to bars. So this kind of a range might be 5 bars. This kind of a range, 4, 3, 2, and 1. If you've got anything greater than about a negative 60 dB signal, when I say greater, I mean negative 60 up to 0 dBs. That means you're very close to a cell tower, good line of sight, and you've got an excellent signal. Anything that's a 60 to a 75, you might have here maybe 4 bars, maybe 5, depending upon your company, your cell carrier. Good, you're probably in the 4 or 3 range here. Fair, you're maybe in the 3s. Here you're in the 2s. And maybe down here you're going to be in the 0 to 1 bar range, depending. You've got just no signal and you're not going to be able to complete your call. So this decibel stuff, interesting math, different than other things that we've played with, and I'll see you on another time. Bye-bye.